Welcome to the session, everyone. I'm Tamara Yu. I've been with mabl for about 2.5 years as a software engineer. I've always been fascinated by the intersection and collaboration between human and machine, and I love nothing more than empowering users with software that we build. I'm lucky to have Andrew here today as my co-presenter. Andrew, would you like to say a few words about yourself?
Yeah, thanks, Tamara. So again, just want to echo, very excited to be here talking to all of you. I'm one of the sales engineers here at mabl. So that means I get to work with customers daily on a variety of different projects that they're all working on. And what that means for you is I get to kind of share the ways that I've seen other customers leveraging mabl within their own testing environment. And so just really excited to share some of the new ways we can leverage mabl to help your own process.
Great. Thanks, Andrew. So here's what we plan to cover today. We'll start by looking at how to build a single reliable test, and then how to leverage the reusable components like flows and snippets to quickly expand your test suite. And you will learn that with mabl's end-to-end features, you can achieve even more test coverage. And then we're excited to share a preview at the end of the mabl desktop app, which is really the future of training here. So let's dive right in. So let's start from what we already know. The fastest way to create a test is start interacting with the application as a user would, and let mabl record the steps. Once you have a user flow or part of the flow recorded, we can replay and fine tune as necessary. Now, as you interact with an element, mabl captures many attributes about the element. You don't have to tell mabl to locate the element by ID or CSS class or so on. mabl will intelligently locate the element by matching against its profile. Now, occasionally we encounter elements that have very few identifiable attributes, and mabl will automatically try to find that element by way of a more reliable identifiable ancestor. And so you can see what mabl has captured, whether it's the target element itself or the ancestor, using the show step information option in the step menu. Well, applications change fast, especially in the era of continuous delivery. Now, down the road, if the elements change, you don't have to worry, because mabl will find the closest match and attempt an auto heal to complete the task as a real user would. We continuously update our knowledge of an element. And so you can see the history of those updates from the test output page. Now, a couple of things to keep in mind here. One is minor changes like positional shifts or sizes, minor size changes are saved when the element is found, and more significant changes which qualify for auto heal are saved if the run passes. And another thing is that steps that interact with the same element are auto healed together. Which brings us to the final point, which is really important here, is that it's important to add assertions as guardrails. Now, we all know that good tests use assertions, but adding assertions here as checkpoints in the user flow will ensure that you have reached the certain application states, which means that with assertions, they allow tests to fail fast and prevent any bad auto heals. Now, there are some situations where it can be tricky to target the right element. To train like a pro means that we can recognize those situations and provide additional input to mabl to make the right decision. We have already discussed using assertions to provide feedback to mabl's auto heal algorithm. And here we will go over ways to configure the recorded find steps to handle these challenging cases for auto heals. Now, one example is when there are multiple similar elements, often laid out in a list or grid, similar to what you see here. Now, consider what happens in future runs if similar elements are added or removed, rearranged, or updated. Is it okay for mabl to pick any of the similar elements? That's a question that only the user can tell us about. And so we recently released a new feature where the trainer will detect situations like this and proactively prompt you to provide the additional context by telling mabl what features about the element is the most important. So another challenge that we find is dynamic data. So this is especially common for tests that involve CRUD operations, where each time a test is run, it generates a new object with a unique ID, name, creation time, etc. But fortunately, in this case, data-driven testing practices come to the rescue. Because if you use values stored in variables to create the test objects, then you can use the same variable to find elements related to that object by incorporating the variables in the find criteria, such as what we show here. And you can easily test many scenarios with the exact same test this way. Now, one last thing is that with modern web applications, they typically rely on asynchronous events to complete operations and update application states. So when attempting a find, if mabl sees that the page is updating, it will actually automatically wait for the page to stabilize first. So that means that generally you don't need to add any explicit or implicit wait in your test. But if you expect that a condition is going to be met with a delay of, say, like more than 10 or 15 seconds, then you can add a wait until step for that condition, such as waiting for an element to appear after the operation is done. Now, wait until steps are very efficient. They are done waiting as soon as that condition is met, or when it exceeds that maximum wait time. So it's effectively like an assertion that you use to ensure that application is in the right state before moving on. And there you have it, like with configure find and wait until, you can leverage mabl's sophisticated find logic and customize it to ensure the correct behavior, even in these challenging situations. So we talked about using mabl's adaptive find, which can handle the majority of the scenarios. And we talked about configuring those finds to ensure that they target the right element in even those tricky scenarios. The last option, which is the most technically involved and also potentially requiring more maintenance, is to use custom CSS selectors or XPath queries to locate elements with as much specificity as needed. I would like to share a few tips just to make sure your custom selectors are reliable and maintainable. Because XPath is more powerful and versatile than CSS, so that's what I'm going to focus on today. So first, you want to avoid full XPaths. So instead of constructing your XPath, instead you want to construct your XPath queries relative to landmark elements using stable attributes. So for example, you can create an XPath for a context node, such as the top site region on this page, and then use that as a prefix for target elements within that context. You can use variables to store XPath fragments so that you can reuse them across steps to target different components inside the same area. And speaking of landmark elements, XPath axes like ancestor, descendant, preceding sibling, following sibling are all very handy for querying an element relative to another element nearby. And you can use different comparators for attributes as well. So in addition to equals, there are contain, starts with, ends with. And finally, by using variables, you can target different elements in a collection simply by changing the value of the variable. And mabl supports variable interpolation in the custom selectors, such as this. Okay, so since interacting with the right element in a page is such a fundamental part of UI testing, I wanted to make sure everybody walks away from this session understanding the full range of options there and how to effectively use each of them. But I have a couple of extra tips for building a fast and reliable test. And so the first thing is that every time mabl runs a test in the cloud, it launches a new container with a clean browser. So you really want to make sure that when you train your test, it's done also in a similar clean environment. And so if you haven't already, you can try the mabl CLI, which is a really fast way for launching into a training session with a clean browser, and you can use it just like in a normal browser. Another thing that we sometimes observe is that for certain test web applications, there might be interference between the application and the training that's embedded in the app page. And so when that happens, you can always open up the trainer in the DevTools window. And so that will remove that level of interference. And finally, I want to leave a couple of ideas for streamlining your test. One is that you want to use deterministic logic as much as possible because it's just easier to reason and easier to debug. And the second one is that you want to, if possible, remove any extraneous steps that will make it run faster. And the last point here, and Andrew will delve in much more depth, is to use API steps to stage test artifacts. So for example, if your test is trying to delete an artifact in the UI, the normal way is you can create that artifact through the UI and then you get to the delete step. But if possible, you can also make an API call that will create that object really fast. And so you can focus the browser test inside the UI test on just the logic that you're most interested in testing. And with that, I'm going to turn it over to Andrew, who will talk a lot more about flows and other advanced features in the trainer.
Great, thanks, Tamara. So as Tamara mentioned, I'm going to kind of touch upon some of the other advanced features within mabl and how they can all kind of be leveraged to help increase your coverage of those end-to-end test scenarios you might see in your application. So if you've used mabl for any amount of time, chances are you're familiar with flows, but they can do so much more than just logging into your application. They are a great way to define a set of steps and import throughout your workspace, but we can also leverage them in some other ways, such as using parameterized flows and looping flows as well. So parameterized flows are a great way to be able to repeat a repeatable set of steps within your application while managing parameters as needed in that step. A good example is sometimes we'll see a set of users with some expected attributes for each user. And so that sort of set of assertions to that user could be wrapped in a parameterized flow where we simply manage those expected attributes as parameters within that flow and then repeat that flow throughout our test. We also see things like being able to create looping flows to test all sorts of stuff like lazy loading scrollers, or even using and combining that with conditional logic to do things like closing multiple virtual tabs in your application in, say, a Salesforce instance. So a lot of flexibility with your flows to kind of be more than just a one-trick pony, if you will. So let's go to the next slide. So I'll talk a little bit about JavaScript snippets as well, which in the same vein as flows, really a powerful tool in its own right. And in the similar way, we can use those across our workspace and share them with other users in our testing environment. And so mabl actually maintains a repo of JavaScript snippets that you can leverage. You'll find all sorts of useful different ways to improve your testing using these snippets, such as the example you're seeing here, where we're essentially generating a dynamic date using JavaScript. We're then reformatting that date into a string that matches the attribute of this element data test ID. We can then pass that variable as the expected attribute, expected value of that attribute, and then select our dates within that date picker in a more dynamic way. We can also do all sorts of other things using JavaScript. The sky's really the limit as far as what you can do creatively using JavaScript snippets. Next slide. And so as Samara mentioned before, end-to-end API test steps are really, really powerful, and we can use them in a variety of different ways. So we can use API test steps to validate the back end of some sort of front-end interaction. We can also combine those API test steps together. So if we need to generate some sort of authorization token in one test, we can pass that token into another API test step using that previous call. And then finally, one of the most exciting ways that you can really use API test steps in the context of an end-to-end scenario is the ability to generate fake user data or a fake user within your application using an API call. And we can even pass in parameters to that API call using some data-driven values such as a user, a billing address, and anything you might expect to be associated with that user. And so if we go to the next slide. So continuing along this sort of thought process of testing a full end-to-end journey in your application, something else you might want to do that previously might have been very difficult is testing your email services. With mabl, since we give you the ability to generate this mabl mailbox address that you can use within your application, you can then pass that as an input value to any sort of email service that your application has, and then receive the response from your application right in the trainer, where we can then open that email as an HTML document and parse through its contents and validate or extract any of that data for validations further down the road. And then the next slide. And another piece to that is being able to download the PDFs attached to those emails. So in a similar fashion, we're going to be able to download any PDFs attached to your emails. And in a similar way, we can open those up and then extract any data for further validations or make assertions against any of the content within that PDF. And then my last slide. So putting it all together, this is sort of the holy trinity, I think, of end-to-end testing: API test steps, mabl mailbox, and then PDF downloads. When you put it all together, you're able to really get a full end-to-end coverage of your application. So we can generate a user via API to test our application. We can then go through our application and trigger those different services like email and PDFs, and then make assertions and extract data for validations within our application. And then finally, we can tear everything down either through the front end, or as Samar had mentioned before, we can again implement that API to very easily tear down that data using some sort of parameter, such as the mabl email domain that you'll see attached with any mabl mail that we create within our application. So you can see how when we leverage all of these tools together, it really lends itself well to that paradigm of setup, test, and then tear down. And that's all I had for you on the end-to-end testing and leveraging all of those tools within mabl. So with what time we have left, I'd like to pass it over to Tamara to show you what's ahead.
Great. Thank you, Andrew. So as promised, we wanted to show you what the mabl desktop app looks like. And this is a really powerful way of just basically combining training and running all in one place in a single desktop app. So I'm just going to show you a quick video of it. And here you can see that we're in the desktop app, but it presents all the information that you would normally see in the mabl web app. And we can quickly launch a new training session, which launches a clean browser. And we can get to it just like you can today. So let's go ahead and go to Wikipedia, maybe test out the search functionality. And like any good test, we would add an assertion to make sure that the search did work and we landed into the desired page. And now once we save and close the session, you're brought back into the application and where you can actually run the test. Now, in addition to what you normally see with the Cloud Run, you now get the option to run the test locally, exactly as it just recorded. And here we go. You can see that it's actually really fast. And in fact, there is actually a headless option, which does not present the browser UI, and it's even faster. And within the same application, you can go to Cloud Run and choose multiple browsers to test that in the cloud. And so now you see that we have 2 tests starting, and when those tests finish, you would get the results right there with you. And so this is a new platform for us to bring that training experience to you. And yeah, so we find it really exciting, and we hope you do too. And if you want to get early access, then you can join the program. We always love hearing from our customers so that you can really influence the direction of the development here at mabl, and we want to bring you the best training experience. So we hope you continue to join us on this ride. And with that, Andrew and I will love to take any questions that you have. Thank you for your time today.
Awesome. Thank you, Andrew. Thank you, Tamara. What questions does everyone have? If you would like to submit questions, please do so through the Q&A panel on the right side of your screen. I have a couple of questions lined up that we can get started with. So Andrew, Tamara, what is the best mabl advice you can give to enable automation of web apps running only in non-Chrome browsers?
That's a good question. So yeah, as you know, the Chrome extension, or the mabl desktop app primarily works through the Chrome browser. So if you can test with the Chrome browser, your app works in the Chrome browser, then I would say like record a test there, and then use the cloud runners to run on the other platforms. The one piece of good news I know is that all the clouds, the browser technology are converging. So even with Microsoft Edge, it's going to be, the next version is going to be using the same underlying infrastructure as Chrome and Firefox already do. So I think a lot of that technology is going to converge and make it more easier, make cross-browser application work more easily, and make the testing cross-browser more easily.
Awesome, thank you, Tamara. Ingesting external data from a file is part of an E2E flow. What are the tools in mabl that we can leverage for this?
Yeah, so depending on what you're ingesting within your application, you can of course import CSV files as data tables for data-driven scenarios in your testing. But also if some part of your end-to-end flow includes uploading a file to your application and then maybe verifying that the upload was successful, you can walk through that whole process within your application testing, just as you normally would. And mabl will make a mirror copy of that file as you train the test, and we can then pull upon that file saved to our cloud on later executions of that test. So a lot of flexibility to be able to include file ingestion within your test.
Great, thanks, Andrew. Are you looking into adding a capability for mabl Trainer to comment out steps that we don't want to be included in the run now, but is needed later?
That's a cool question, because that's exactly what my team is currently working on. So we're hoping to have something for you soon.
Awesome, that's exciting. Thanks, Tamara. Let's see. I see mabl sometimes prompts me to provide context because similar elements are found. Does that mean I shouldn't need to I shouldn't need configure find otherwise?
Yeah, so I can take that one.
Okay.
So yeah, so mabl is trying to get smarter and recognize those tricky situations, but based on what we see as similar elements on the page. So, but occasionally, if you, for example, don't have those like similar elements when you're training, mabl may not recognize that because it doesn't know what it doesn't see, right? So in those cases, that's when if there's like dynamic data involved, if there's going to be similar elements like in a table, grid sort of things. So you could always go to the configure find option in the step menu and add those criteria, because it will really help make your test more reliable.
Thanks, Tamara. Do you all have any tips for debugging custom JavaScript steps? When the step fails, I don't know whether it's because of a bug in the script or if it is a test execution issue.
Yeah, I'll take that one. So I find often a really useful way to kind of preview what we can expect out of our JavaScript steps is to actually run the code in the code editor. And using that callback feature within that function, you can kind of get a preview of what is being executed within that JavaScript code. So just like for instance, if I'm relying on formatting a string in a very particular way, I can call back that string as a variable and then get that preview of that string and just ensure that it's sending out the right format of that string when I execute the code. Any color to add to that, Tamara?
I think that covers really well. The one thing I can imagine is maybe like opening up the browser console, and so you can always test out little snippets against the page there. But it's very similar to just like testing it in the mabl console, the mabl JavaScript editor.
Thank you both. Any best practice recommendations on running the same E2E test suite on different customer data profiles?
Interesting. So I think there's a couple of ways to approach that. What I've seen is oftentimes customers will have a single end-to-end testing suite as a skeleton where they can essentially swap out the different user profiles into certain places in the test. And to leverage, the parallelism offered by mabl, they set up their tests to all run off of a data table, so that anytime they need to add another user scenario, rather than having to refactor the tests at any point, they're simply creating another row in their data table, which will represent a new user scenario represented in that end-to-end test.
Cool. Thanks, Andrew. How does mabl detect similar elements?
Sure. So the way that mabl detects similar elements is very similar to how we actually find the elements. We look at like all the elements on the page and what their attributes are, and if there are a collection of them that we find that have similar attributes, and by our scoring system is almost indistinguishable, then we'll treat that as potentially candidates for similar elements. But another criteria that we apply to it is to capture those cases where elements are aligned. And that's another really good signal for us that they are some kind of repeating pattern. So that would generally capture things like in tables and grids. So we look for alignment and we look for attribute similarity.